This video is the next video in the algebra set of videos, and in particular, in this video, we're going to be looking at linear inequalities. Now, there are 4 inequality signs that you should remember from even primary school. We have greater than or equal to, less than, and finally less than or equal to, and they're listed there 1 to 4. Now, the most important thing to remember when we're dealing with inequalities is that we deal with them exactly the same as when we have an equal sign, apart from one exception. And that exception is when we divide or multiply by a minus, we must change the direction of the inequality. So for example, if we had minus x is less than minus 3, and we divided everything by minus 1, or we changed the signs, it would become x is greater than 3. Now, before we look at solving linear inequalities, we're just going to go through plotting numbers on a number line when given the different types of numbers, and also when looking at the inequality signs. The first type of number we're going to look at is the natural numbers. Hopefully you can remember that the natural numbers are our counting numbers, and just like you would with apples, you always start counting at 1, and they're positive whole numbers. And the thing is, if it has an n, it's a normal natural number. Example 1 here says, draw x is greater than or equal to 3 on the number line, and x is an element of n. Now, as this is x is greater than or equal to, it could be equal to 3. So we colour in the 3 because 3 can be included. It's greater than, so it could be 4, 5, 6, and it could be any number greater than 3. So we include the arrow, so we shade in the arrow on that one. One thing to note as well is because it is a natural number, we don't colour in any other part of the number line. We just have our dots on the numbers, as when we colour it in, we're including all of the numbers between 3 and 4. So for example, like 3.5 or 3 1/8 or 3.25. But none of those are natural numbers, so we don't shade in the part between the 3 and the 4. The second type of numbers we have are integers, and hopefully you can remember that integers are positive and negative whole numbers. They're very similar to natural numbers. They include all the negative whole numbers though, and they also include 0. An example of plotting that on the number line then is very similar to the first one. It says here, draw x is less than or equal to 3 on the number line, and here x is an element of z, which is the integers. For this one, x is less than or equal to, so we include the 3 in this as well. And it's less than, so it's going left down the page, and it only includes the whole numbers, both positive and negative and 0. And because it's less than, it can go on for any number. So it can include minus 7, 8, 9. So that's why we colour in the arrow as well. Type 3 is the set of real numbers. Now, the real numbers contains all the numbers on the number line. So a full heavy line is used for OR. And a way to remember the real numbers is OR for random. So they're just random numbers. Any number you can think of, it's a real number. Example 3 here, it says draw x is greater than or equal to 2 on the number line, and x is an element of OR. So this is greater than or equal to 2, so we can include the 2 in it. It's all of the numbers greater than that, including the fractions, decimals, irrational numbers, and so on. So we colour in the line between all of the numbers and the numbers themselves. We continue with the arrow as well, as the numbers go on forever. And one thing to note, which we'll have more practice of when we're doing a few examples in a second, we use a solid dot for less than or equal to and greater than or equal to, and a hollow dot for less than or greater than, because the number that they're talking about isn't included when we talk about less than or greater than. But again, that can be explained by going through a few more examples. In example 8.1 here, it says graph each of the following inequalities on a number line. The first one we're going to look at is x greater than or equal to 3. So first thing I'm going to do is draw my number line. Your number line doesn't need to be amazingly accurate, or the spaces don't have to be perfect, but it should resemble what a number line should look like. So don't get too blasé about it. In this particular one, we're looking at x greater than or equal to, and we have 3. So it's greater than or equal to, so we can colour in where 3 is. It's greater than, so it's going to the right. And its x is an element of n, the natural numbers. So we can colour in all the natural numbers. However, we need to not colour in the spaces between it because it's only the natural numbers. It's not rational numbers or fractions or decimals or irrational numbers. So for example, it couldn't be 3.7. Example B has x less than or equal to 4. Again, start by drawing my number line. Again, making sure that you have an arrow either side as well. Here we're looking at x less than or equal to 4. So we include 4 because it's the equal to. And this is an integer. Z are the integers, which are positive and negative whole numbers, which include 0 as well. It's less than, so we're going down the number line and the numbers are getting smaller. And we include the arrow as well because this could go on for infinity. One thing to note again is that we do not shade in between the numbers this time either because integers are whole numbers. They don't include fractions or decimals. Part C, we have x less than 1 and x is an element of the real numbers or. Again, for here, I'm just going to start by drawing my number line. And in this particular one, we have x less than minus 1. Now, as this is less than minus 1, and it's not less than or equal to minus 1, we put a hollow circle around the minus 1, because it can include everything up to minus 1, but just not minus 1 itself. This is x is an element of the real numbers, and the real numbers can be any number. So for this one, we colour in the arrow, but we also colour in the line because it could be any of the numbers, minus 4, minus 3, minus 2. It could even be minus 1.5, but we don't colour in minus 1 itself because minus 1 isn't included. D then is x greater than or equal to minus 3, and x is an element of the real numbers. I'm drawing my number line here. Now we have x is greater than or equal to minus 3. It's greater than or equal to, so we have a filled in dot at minus 3. It is greater than, so we're moving to the right, and it is the real numbers, so we colour in the line that we have here. We also colour in the arrow because that can continue forever, and we can also, if you want, colour in the other numbers here, whole numbers. Now that we've had practice looking at drawing or graphing number lines, we can look at solving linear equations next. Example 8.2 says solve the following inequalities and show the set on the number line. In part A, we have x minus 1 is less than or equal to 4 and x is an element of n. Now, if you remember at the start of the video, I said when we have linear inequalities, we solve them exactly like we would any linear equation. However, we just have to keep in mind if we have multiplied or divided by a negative number, we flip the inequality. So here, I'm going to solve this as I would normally. We find out what x is, so I'm going to plus 1 to both sides to get the x by itself, and we'll be left with x is less than or equal to 5. Looking at that then, have we divided or multiplied by a negative number? We haven't, so we leave the inequality sign alone. Then we have to show the set on the number line. I'm going to draw my number line. This here is x less than or equal to 5. It's less than or equal, so we can colour in the 5. And it's the natural numbers. Now, the natural numbers are the positive whole numbers, and they're the counting numbers, so starting at 1. So this could be 4, it could be 3, it could be 2, or it could be 1. It couldn't be 0, -1, -2, -3 because they're not natural numbers. And the most important thing is that we have only the numbers that it says we're allowed, which is the natural numbers. The next one, B, is 5 minus 2x is greater than or equal to -7, and x is an element of OR. Again, I just solved this as if it's a normal linear equation. I want to find out what x is, so I'm going to first of all remove the 5 from both sides, and I'll have minus 2x is greater than or equal to -7 minus 5, which will give us minus 12. And then I want to get what x is. I now have minus 2x, so I divide both sides by minus 2, and I'll end up with x greater than or equal to 6. Now, I have to bear in mind, have I multiplied or divided by a negative number? And I've divided by minus 2. So this inequality sign here is going to flip, and what we'll have is x is going to be less than or equal to minus 6. Then we draw this on our number line. Here we have x as an element of the real numbers, and it's less than or equal to. So we colour in the 6, the dot on it. It's all the way down on the number line because it's the real numbers, and we colour in the line because it includes absolutely every possible number from 6 downwards towards the negative numbers. C is 5x plus 7 is less than 3x plus 3. Again, this is just a linear equation. It's a little bit more complicated than the last one because there's more than one x, but we solve it exactly with a linear equation. We just assume that the inequality is an equal sign. I want to figure out what x is, so first of all I'm going to bring all the x's to one side, so I'm going to minus 3x from both sides. We get 5x minus 3x is 2x, then plus 7 is less than 3. As the 3x and the minus 3x will cancel. Then I want to get rid of everything else from the left hand side where the x's are. So I'm going to minus 7 from both sides there, leaving me with 2x is less than 3 minus 7, which will give us minus 4. And then I'm going to divide both sides by 2 to get what x is by itself. And I'll get that x is less than minus 2. Again, I'm just going to plot that on my number line. This is x is less than, and in this particular case we have x as an element of the integers. So when x is less than minus 2, so because it is an integer, it's a positive or negative whole number, and it's less than, so it actually could be only minus 3 and then whatever numbers are down there. We don't even have to put in a circle, hollow circle around minus 2 because, well, it can't be minus 2 and it's an integer, so it can only be a whole number. So the closest whole number below negative 2 is minus 3. Part D is 4 times x plus 2 is greater than or equal to 3x minus 4. And here x is an element of the real numbers. Solving this, we're going to start by multiplying the bracket. So we have 4 times x and 4 times 2. That will give us 4x plus 8. That's going to be greater than or equal to 3x minus 4. Next, I want to bring all the x's to the left-hand side. That will leave me with x plus 8 is greater than or equal to minus 4. And then I'm going to minus 8 from both sides. And that will leave me with x is greater than or equal to minus 12. This is quite a low number, but before I actually do anything, I just check to make sure I haven't divided or multiplied by a negative number, and in this case, I haven't. So I do my number line, but because it's all the way down at minus 12, I'm actually going to start my number line here at minus 13. This is x is greater than or equal to minus 12. I can colour in the circle around minus 12. It's a real number, so it includes all of the numbers greater than minus 12, including decimals and fractions, and I colour in my arrow as well because it can go on for infinity. After watching this video, you should be able to solve any linear inequality. The main thing to remember with an inequality is if you multiply or divide by a negative number, you have to flip the inequality. Always remember as well to show the set of answers on the number line. When you solve an inequality, that's what they want you to do. Have your number line out and show the answer on the number line. That brings us to the end of this video.